Before we jump into some distance and midpoint formulas, let me go back and refresh you on something from geometry. This is a big word, but everybody knows it. Pythagorean Theorem. Oh, no. Y'all didn't know the timing scheme.
And the wheel. At the wheel.
Oh, it's here. Okay, now you can see everything. What is the Pythagorean Theorem?
A squared plus B squared.
That's exactly right. A squared plus B squared equals C squared. When do you use it? Triangles. What kind of triangles? It's a special kind of triangle. Right, somebody said it. It's a right triangle. It could be isosceles, but it's got to be a right triangle. That's the key. What is a right triangle? They said go. All right, tell me what a right triangle is. 90-degree angle, that's right. So it looks like this. The little square indicates 9 degrees. So you told me a squared plus b squared equals c squared. What does that mean exactly? The length of the two legs squared added together is the square of the hypotenuse. So what I'm getting at is this is C and these are A and B. And it doesn't matter which one you let be A and B. They just have to butt up to that right angle. Y'all got that? Okay. So we'll use that in just a little bit for something else we're going to do. But let's get back to the Cartesian plane. Let's talk about distance. Distance. Tell me this. If I have a line segment, and think about this segment being on a number line itself. So let's say that this happened at 2. We talked about this a little bit yesterday. And let's say that this was 10. How would I find the distance between those 2 points on a line segment? I want to know how far between them it is, though. How do you find the distance between the two ends? Y'all are way overthinking it. Subtract the two of them, right? Subtract. So the distance would be 10 minus 2. You want to make sure it's absolute value. Why? Can you have a negative distance? No. You can't have a negative distance. So to find the distance, we just subtract, and so we would get 8. So if the endpoints were, we'll make it more general, A and B, then the distance between A and B would be the absolute value, because I want to make sure it stays positive because distance is not negative, of what? What do I do inside those absolute values? Subtract what? A and B, that's right. So I can actually do A minus B. But because I'm in absolute value, this is the same thing as B minus A. You agree with that?
Sure, why not?
What's 10 minus 2? 8. What's 2 minus 10? Negative 8. If you take absolute value of both of those, they're both what? 8. Positive 8. Good job. All right, so of course we're going to build on this a little bit. That's on a line segment, but what if that line segment happened, and this is a geometry review for us, what if that line segment happened in this Cartesian plane we've been talking about? Let's say, we'll put it here. Let's say this is -1, -2, and let's say this is 4, 1. And together, these are the endpoints of a segment. Now I can't just subtract because it's a little bit harder than that, right? Does anybody remember how to find distance in? You're very close. It's actually a derivation of the Pythagorean Theorem. Huh? Well, that would give you slope. So you would do that for slope. But to find distance, it's a little bit harder. Here's what we're going to do. You'll probably remember this formula when you see it. But you're absolutely right. This is a form of the Pythagorean Theorem if we were to form this with a triangle. It's the square root of. You subtract the x's, and then you square them. And then you add it to the difference of the y's squared. It looks harder than what it actually is, right? If you think about what it is you're doing. The first part is just the x's. You would just subtract the x's. And the order doesn't matter because when you square it, it's making it positive, right? So it's kind of like an absolute value deal. Mr. Matthews? He was upstairs. Okay, so it really doesn't matter this order so much because we're squaring it, we're making it positive, right? All right, so look at the example here. How would I find the distance? What do I do? I'm going to do my square root, my radical. I heard some of you said -1 and some of you said 4. Does it matter? No, it does not matter. I'm going to do 4 first. Minus -1. Be very, very careful about those signs, okay? Square it. Plus. Now what? 1 minus -2. Again, it doesn't matter. I always like to start with the positive. It helps me. So now, what happens when you subtract a negative? It turns into a positive, right? I'm adding. So I get the square root of, this becomes what? I'm just going to write step by step so you see. So if you go back to look at your notes, you can see exactly what we did, where everything came from. 1 minus -2 would be what? 3. And if you need to use your calculator, square exactly, don't forget that squared, then go ahead and type that in your calculator just like that. All right, so 5 squared is what? 25. And 3 squared is 9. What is 25 and 9? 34. So the length of that segment is the square root of 34 units long. No. Is it okay to leave your answer like that? If there's no perfect square, and then take you back to algebra 2 and algebra 1. If you can't divide it by a perfect square and simplify it, do y'all remember simplifying radicals like that? Yeah. So, yes, I could leave it like that. If you want to give a decimal approximation, that's fine too. But that's how you find the distance between 2 points. Everybody okay on that? Y'all want to do one more? You okay on that one? One more. Let's do one more. Let's say that I have the points. I'm not even going to draw it for you this time. I'll just give you the points. Y'all try this one on your own, see what happens, then we'll come back and do it together. Find the distance between those 2 points. I made the first one up off the top of my head, but this one I pulled out of the book. I can't believe it's the same exact thing.
I did it a different way. Oh, yeah, I did it 1 minus. Yeah, I did 1 minus. It still won't be.
Okay, but you still get right because 6 minus 1 is 5. 2 minus 1 is 1, not 3. Did y'all get 3? What? Oh! Oh my goodness. I gotta do better, I do. But you're right. It is, but it doesn't matter because you're squaring it. You see what I'm saying? So if you do this, that's the same thing as 9, yeah. I should probably still put it though, you're right. Wow, y'all. I bet I couldn't do that again if I tried.
You should remember this phone recorded?
Yeah.
She's still recording.
I'm telling you, I need to buy a lottery ticket today. let me ask you this. Let me build on this just a little bit. Let's say I told you that these were 2 points, 2 vertices of a triangle. And the third vertice of the triangle was -3, -2. Could you find the perimeter of the triangle? If you think about a triangle and these are the vertices, so let's say this is 1, nope, let's say this is 6, 2. This is not going to be accurate at all, so but I'm just saying for instance. And this is 6, 2. Nope. Come on, Stacy. 1, -3, -2. I'm losing track of my points. What you found, this square root of 34, is between 1, 5 and 6, 2. So that's this side right here. Right? What if you wanted to find the perimeter of the triangle? What would you have to do? You'd have to do the same thing for all of them. Then you'd have to find the distance between these 2 points. Right? That would be this side. And then you'd have to find the distance between these 2 points, and that would be this side. And then add all 3 together for the perimeter, right? You have a couple like that in your homework, so I just want to make sure I showed you. It's the distance of each side. So it'll say these are the vertices of a shape, and so sometimes it's easier if you kind of graph them or sketch it so that you can see and you can keep up with which side you found. But just understand that's what you're doing when you find distance is length there of the side. Everybody okay? All right, let's talk about midpoint. I'm trying to get done, I promise. Midpoint. This one's easier than distance to me, in my opinion. If I have, again, a segment. Chandler, give me 2 numbers. 5 and 12. If I wanted to find out where exactly in the middle of 5 and 12 happens, what would I do? How? Okay, so here's subtract. Subtract would give me the distance between, and so you could, and then divide by 2 and find the exact middle. How else might you do it? If you had 2 grades, you would average them, right? That finds exactly in the middle of the 2 grades. So how do you average something? Add it together and divide by how many you have, right? So let's see. 12 plus 5 is what? 17. What's 17 divided by 2? 8.5. 8.5 comes exactly halfway between 5 and 12. So, Jerome, what you were doing is you were saying 12 minus 5 is 7. Half of 7 is 3.5. 3.5 past 5 is 8.5. So, yes, you could do it that way. It's just a little bit longer. Just a little bit longer. So, if we generalize this just a little bit, if this is A and this is B, what would be the formula for finding the midpoint? A plus B divided by 2. So this is all the way back to geometry. But again, let's put this segment in the Cartesian plane. Y'all ready? Somebody give me a point. 4, 1. Somebody give me another point. -3, 2. How in the world can I find the point that is exactly in the middle of those 2 points? The middle's going to be another point, right? It's going to have an x, I'm going to call it xm, and a y, ym, for x midpoint, y midpoint. Well, how can I find the middle of the 2 x's? How do you find the middle of 2 numbers? Average them. That's exactly right. So to find the midpoint, I could take the x's and divide by 2. And do the same thing with the y's. This is a little bit easier than distance, I think. Because it makes sense. Middle, add them together, divide by 2. So what is the x part of your midpoint here? 4 plus negative 3, which is what? 1. It's over 2, so that means at 1/2. Okay, now you find the y part. Tell me what you get. That's right. Add the y's together, divide by 2. Fractions are our friends, so we will leave them as fractions and stop right there. Easy? Add together, divide by 2. That's the key on midpoint. One more little thing to show you real quick. I told y'all this was a long lesson. This is just half of it. We did half of it yesterday. This is the other half. Oh my goodness. What in the world? Oh, they're taking the recycle out, aren't they? I bet they're having to take it downstairs. Oh my goodness.
They should just use that one.
I'm going to skip circle, and I'm going to go into, well, I'm going to skip circle because we're going to get into conic sections and things like that. What I want to do is I want to verify a right triangle. Here's what I want you to do. RT is my shorthand for right, and that's my triangle symbol. I had a lot of symbols when I taught geometry. Let's say I have 3 points. And these are all vertices of a triangle. My question to you is, does it form a right triangle? Why or why not? How might we know? But graphing's not going to be very, very accurate because you're not going to be able to tell exactly. What else could you do? What is special? We talked about the very first thing we talked about. What's special about a right triangle always? Besides that. Keep going. What about the hypotenuse? It's got to satisfy the Pythagorean theorem. A squared plus B squared has got to equal C squared. A, B, and C are sides, right? I got 3 sides of a triangle. I need to use the distance formula to find all 3 sides. Okay, so let's think about what this looks like on a graph. I've got -3, 4. I've got 1, 0, and I've got 5, 4. I need to find each side, and then I need to see if A squared plus B squared equals C squared. Let's do it real quick, and I'll be done. That's the last thing, I promise. I'll let you get on your homework. Let's do this side first. We'll call this one A, we'll call this one B, and this one C, because you can kind of see which one's longer, right? Which one the hypotenuse is. All right, let's find A. Square root of, tell me what to do. I'm looking at this point and this point. 1 minus -3. Don't forget to square it. And then what about the y's? Either way. Yep, either way works. So crunch those numbers real quick and tell me what that side length, what's the side length of A? 4 squared plus 4 squared, which is, yep. Everybody get 32? I'm going to write this over here. You have 1 or 2 like this on your homework, so I want to make sure I went over one like this. This is where you have to kind of apply your knowledge that you learned. It's not just do the distance formula. It's take it a step further. How about B? Let's do length B. So now I'm looking at 1, 0, and 5, 4. See why it's easier if you have kind of a picture there to look at, so you're not, which ones did I do? Subtract the x's. Subtract the y's, and somebody tell me what you get. I'm sure y'all are probably ahead of me. Is it 32 again? 4 squared is 16. That's right. Good job, Drum. Good job. All right, one more side to go. By the way, two sides are the same. What kind of triangle is this, even if we don't know if it's right yet or not? Isosceles. It's definitely isosceles. Let's see if it's an isosceles right. All right, square root of, subtract the x's. Negative 3 minus 5. Oh, that's an easy one. That's 0. That's right. You doing that in your head? Is it a right triangle? And why?
Yes.
Is a squared plus b squared equal to c squared?
Yes.
Is it?
No.
I don't know. I'm asking you. What is a? 32. Square root of 32. A squared plus what is b? Squared. The question is, does it equal c squared? What happens to a square root and a squared? They're opposites. They cancel. So this becomes 32 plus 32. Does it equal 64? Yes, it is a right triangle. You did say that, but you just didn't justify why.